Hey everyone, my name's Shane. I'm from Solutions Enablement. Today I want to run you through a fully fledged end-to-end demonstration of how to install the Micro Focus ArcSight Amazon Web Services CloudWatch connector. You may be aware that we have a CloudTrail connector. We also have CloudWatch, and we've also just released a new Security Hub Smart Connector. But this one today in this session is going to be all about the CloudWatch connector. It's possibly lost a little bit of emphasis from a security perspective because Security Hub will be that place to go to for security events. But CloudWatch can still add a lot of relevance for other reasons, and so we'll go through that today. It'll also help us really understand how the pieces and components within AWS itself actually hang together and how the Smart Connector works to deliver logs and events to your ArcSight destinations. So this is just a little bit more complicated than simply installing just a simple Syslog connector. So I'll start by opening up the CloudWatch PDF from the config guides. I'm actually running the 7.15. We haven't quite got the new version of documentation out just yet, but 7.15 gives us everything that we need. And the thing about the documentation in this version is that it's a little bit confusing in a few areas, particularly the Amazon side of things. So that's why I really want to emphasize and actually demonstrate firsthand how to overcome some of those obstacles. So there's a lot of AWS services involved with this connector, and you don't need to be an expert on any of them, but you certainly need to know what overall role that they play in the architecture of event delivery. So we've got AWS Formation, which is effectively a piece that allows you to, I guess, wrap up what we call Lambda and Kinesis and so forth, and basically build cloud-based applications that are effectively serverless. And that's where this notion of AWS Lambda comes from, where you don't need to deploy instances of Linux and so forth to run the connectors. It's actually all run inside of Amazon, and it's all taken care of for us. And that's why the steps involved to install this connector are a little bit more sophisticated. IAM has obviously been involved, being a cloud provider. We obviously want to provide minimal access to all these components to allow them to do their job of log delivery. This can be quite sophisticated on its own. Obviously, Amazon, if you've worked with EC2 and Amazon policies, they're JSON based and they can be quite sophisticated and confusing at times. Kinesis is another service that we'll be utilizing to take care of our data intake, aggregation, and so forth, and feed it within our Lambda function as well. And Lambda is, of course, effectively that serverless component which our connector basically runs upon. It does the parsing of the Amazon events into Ceph and then delivers them to a downstream Syslog-ng connector or a load balancer itself. S3 also plays a big part here, one in that our Lambda connector actually picks up configuration from this S3 bucket, things like our map files, custom map files and so forth. It also acts as a temporary storage space or a transport cache if and when there are problems with communication between Kinesis / Lambda and also the downstream Syslog-ng connector or the load balancer itself. So think of it as like our traditional connector cache, if you will. You'll see if there are problems, your transport cache folder will start having events put into it. So hopefully you never see anything in that transport cache folder. And we'll go into that later on. In the documentation, we provide a pretty good diagram of how these pieces hang together. So I'll give you a quick run through of how this all works. Starting at the top, obviously VPC flow logs can occur at right down to the per individual NIC basis or network interface level. And so that can generate accept and reject and so forth log events, which can be sent through to CloudWatch. And CloudWatch has this notion of log groups. And log groups are what our connector is actually taking feeds from, taking events from. And effectively each VPC flow log will have its own stream within that log group, and I'll show you those log groups and streams later on in the AWS console, so you get a feel for what they look like and how they are placed. Those events then flow through to Kinesis, which is effectively like our like a message bus, so to speak, in a way a bit like Kafka. And from there, Lambda plays that serverless compute part where it has two components to it. One is the heartbeat. Basically, it's a small Python script that is looking for problems with the load balancer or Syslog-ng downstream connector. Now, you're not just connecting to and sending Ceph straight to a ESM or a logger. It is going to a smart connector, and a Syslog-ng smart connector, or a load balancer, depending on what you want to achieve and what your EPS rates are. So this is this heartbeat piece. And the Lambda heartbeat actually looks for problems with delivery of the messages, and if there is a cut in communication here, those events can then be sent. We can send the event processor piece of Lambda to actually send those events through to an S3 bucket. Now, what's interesting about this diagram is that we've placed the S3 bucket inside of AWS. Yes, it's inside of AWS, but something I want to make a point of for later down the track is that S3 is actually considered an internet side function or a component to AWS. So it's not something that an S3 bucket doesn't sit inside your private VPC. It doesn't sit on your firewall subnets and so forth. So it's something that needs to be kept in special consideration in terms of access to, and we'll get to that a little later on. The second piece to Lambda is, of course, what we call the event processor. An event processor is effectively the Java code for parsing of events, and that's the main piece that does all the processing for us. This Lambda function runs continuously. We don't have to spin up a Linux box. We don't have to worry about file systems and space and memory and all those sorts of things. It's all done for us, which is great. And what it does is it effectively start sending events to our downstream Syslog-ng or load balancer. And again, as I said, if there's any problems in communication, the heartbeat Lambda finds any issues, the event processor will start to push those events through to the S3 bucket. So we can guarantee that there's no loss of events. The next piece to it is the VPC and this notion of private and public subnets. And this is an interesting topic because this is where it can get not so much complicated, but if it's not set up correctly, you will actually see your Lambda event processor actually fail in its ability to actually pick up its configuration from S3. And will also simply not run well itself. So effectively the event processor does need internet access, so to speak. So again, this is why I make the point that the S3 bucket should be considered an internet side component. So we have this notion of private and public subnets, and a private subnet is effectively a subnet inside of a VPC that has no internet gateway, so to speak. It cannot have a public IP address. You cannot have inbound traffic effectively. What that means is if you want to get outside access, if you want your private subnet to have access to the internet, you need what's called a NAT gateway or a NAT device. Originally, Amazon didn't have this service. You would actually have to set up your own router, which would sit in both your public and private subnets and route traffic from the private to the public subnet and then out to the internet through an internet gateway. But Amazon have introduced a new NAT gateway function, which has been around for several years, that actually allows a private subnet outbound only access outside of the private subnet through the internet gateway and out to the internet. And this is really, really important because this is how the Lambda functions actually make their way out to the S3 bucket. And so I want to really stress that point that this part of it is really necessary, and that's where the networking complexity comes into it. So in this install, we're actually going to be creating private and public subnets, and I'll show you how they all hang together and how we set up the routes and the NATs and so forth to make this all work. You only need to do it once, but once it's up and running, it's extremely reliable. And you'll notice that it's not until we get to this point here, way down here, that we're actually sending to a real ArcSight destination, so something like an ESM or a logger. The important part to note here is that we're going to be placing our Syslog-ng in the private subnet. So if you wanted to place your ESM or your logger, say you're doing a POC for example, you could place your ESM or logger in the private subnet, or you could allow it sit it in the public subnet so you can actually get external access to the admin GUIs, for example, from the internet. But you're going to need to make sure that obviously those instances of logger and ESM have access or NICs inside of the private and public subnet. So keep that in mind. So there's a number of actual pieces that are required to set up this solution. We utilize VPCs. We're creating a private subnet and a public subnet. And you'll notice that the instructions in the config guide sort of pushes around different pages. So starting from the prerequisites, we go to page 17, we can come back to page 10, etc., etc. So it can take a bit of toing and froing to actually get this connector installed. But the prerequisites list are very, very good in that we utilize a VPC. It doesn't have to be a new VPC. It can be existing. You can use a existing public subnet. It doesn't have to be created from scratch. The important thing to keep in mind is that you must have one. You also want to create a private subnet. Your customers and yourselves, you should be using private subnets anyway, but the Lambda functionality, so our event processor must run in a private subnet, and that's why you have to have them. You want to be able to connect from an EC2 instance in a public subnet to an EC2 instance in a private subnet. So one way to do that is either through routes, or you could just have dual NICs on your EC2 instance. And when we say an EC2 instance, we mean the Amazon EC2 Linux instance that you'll be needing to deploy to set up the connector. The IAM user with the required privileges, that takes some time. There's quite a few steps. We need to create policies and so forth. You'll notice some JSON sitting in the actual PDF here, and you'll need to cut and paste that in, obviously being careful to make sure that you get it right. We're going to create an S3 bucket, and in the S3 bucket not only has our transport cache that I mentioned before, but it also contains several files such as external.properties, which we'll go through soon. It also include the event processor.jar file, which is effectively our connector, if you will, our parser. And we're also going to need to bring in our Syslog-ng and load balancer or load balancer certificates. And the instructions tell us where to actually pull those files from. This is the external.properties file, and although it's nicely commented and so forth, you can actually just sort of shortcut that with a small number of pieces of information. So if I bring mine over here, this is effectively all we need. And this file is going to be uploaded to the S3 bucket. The event processor will pull that file down and get information about where to find the relevant files that it needs to run as a connector. So what we've got here is host.name is basically our Syslog-ng box, and that's its IP address, what port we're going to be connecting on, what our certificate bucket is. So in other words, which S3 bucket are we looking for, which are we going to get our remote management certificate. It's a .p12 file, and the actual key itself is certificates / so I've just simply put it under a subfolder. And the certificate password, as you know, for our management certificates by default for any ArcSight connector is of course change it. Send retries, in terms of sending an event. If that fails, then start sending my events to this bucket under this subfolder. So that, as I said before, this is our transport cache folder. And that can be any name you like. We'll just keep it as default. We've also got the ability to upload custom map files. One of those examples might be Linux logs, for example, which we've added in 7.14 if you're using an older version of the connector. But if you've got custom map files that you want to place, you can actually place them in a subfolder as well. And you'll notice in the event processor, Log files within Amazon will actually show a log entry saying it's loading up map files if it finds them. So it's quite useful. Log level, if you're having problems, probably best to push that over to debug, but I've found that .info is quite okay. So that's our external .properties file. So we'll park that to the side for now, and that's effectively what this piece of the documentation is running through here now. And what's important is that once we've got that set up, we're going to upload it. We need to set up an AWS account, and this is our authenticated user to allow us to run and install and configure and so forth the overall connector. And there's a few pieces to it, but it's relatively straightforward. First thing to keep in mind is that the instructions here in 7.15 are a little bit off. What you need to do is go to the IAM console, and firstly, sort of ignore these two first lines here. They don't make a whole lot of sense, but what we're doing here is creating a new policy in JSON. Simple as that. And this first JSON policy is giving us effectively allow access to creation of CloudFormation stacks. Simple as that. That's basically where this whole thing starts. We create the stack, creates the Lambda functions, Kinesis, and so forth. So this is sort of our starting point where we need to go for the user. So we'll do that. That's our first policy. We'll save it. We'll give it a name. CloudFormation Basic Execution. That's a pretty good name. I'd leave it at that. We need to create a second policy as well, which again is another JSON policy. This one's a little bit more long-winded, but this gives us, I guess, more permissions, minimal permissions to various functions such as Lambda, IAM, EC2, Kinesis, and even S3 to do its task of setting up the connector. So as I said, as we saw in the architecture diagram, there's quite a few components involved. So that's the second JSON policy you'll need to basically copy and paste into a new policy, give it a name. I tend to use something a little bit more useful and meaningful than limited permission, as per what the documentation suggests, and I'll give you an example of that. We then create the new user, as you do in IAM, just like any other user, give them a username. The documentation says the access type should be programmatic and management console. Unless the user needs management console access, perhaps if you're on a POC and your customer gives you a management console access user, that may be relevant, but essentially we're doing all of our access and work programmatically, so it's up to you whether you want to give management console access. Create your own custom password, and then once we've finished all that, we then go over to permissions, and this is where we have to do a couple of steps to actually assign the correct permissions to this user for the purpose of the connector install. The first thing what we overall need to do is we're attaching a whole bunch of existing policies, because we're going to be attaching Amazon policies, and we're also going to be attaching our policies, those JSON policies that we just created in the previous steps. So the first two that we want to attach are the two that we just created, and then we're going to attach all these other ones. Once we've done that, we then create the user, we review and then create the user, and then we create an access key and secret access key, which is what we use in the connector install to actually authenticate and perform the functions that we need to in order to install the stack, Lambda, Kinesis, etc., etc. So that's really important that we get a copy of those. We're going to be creating a CloudFormation stack, as we said. It's sort of all done through the connector install on our EC2 instance, and we'll get to that shortly. It's best to install your Syslog-ng connector sooner rather than later. Now, it's interesting to see that we're not necessarily sending our events from the event processor straight to ESM or Logger. We're sending it to a Syslog-ng or load balancer first, and we have to do this for redundancy and performance. And what we need to do is, of course, have a Linux box or a Windows box that will be that Syslog-ng connector. The reason why we do perform this step sooner rather than later is that we can actually get a copy of the remote management certificate and keys, so that we can pop those into our S3 bucket. And from here, this next piece around the manually configuring of the AWS CloudFormation stack, we're going to create a nice new clean network in the AWS console now. So we tend to sort of do away with needing this piece here. But the important thing to note here is that private and public subnet are both required for this actual connector install to be successful. And if you don't and follow all the steps exactly, it will fail. You will not get logs. So let's move on to actually creating the network that we need to install a connector. I think that's a good place to start, because it gives us a good blank canvas of a network to actually work from, and it will really help explain why we do what we do in the connector install. So let's do this from scratch. Create a policy as per the documentation. You can use this visual editor if you wish. It tends to not make particularly granular policies, in my opinion. You're better off going with what the config guide has in it to be absolutely sure that you get it right. So this is our first policy. So we delete what's already in there, paste in the new stuff. There's our first JSON policy around the CloudFormation capability. Review the policy. And what's really nice is that the summary then goes and shows us what we've got capability to do. So CloudFormation is the service, what sort of access level we've got, and what the resources are. So that makes it really easy for us. So I'll give that a name. And a bit of a description. And that's our policy. That's our first policy. And so that's done. It's been created. Great. We can create the second one. Again, go into JSON. Delete what's already there. Paste in. Just be very careful that that's all correct. It won't allow you to move to this next stage if there's any problems anyway. But if you're cutting and pasting, obviously, out of a PDF, you've got to be careful that you don't get those headers and footers in amongst the JSON, or it will mess it up, obviously. Okay, so I've got an error in this. I'm going to have to go back and work out what I've done wrong. Alrighty, that's all fixed. I can now review that. Again, I'll give it a name. I like to give it a slightly more useful name. And what's important is that give it a bit of a decent description as well. So limited permission to create and modify resources as necessary. So again, looking at the summary, it shows us all the different access to which services, what type of access they've got to, and so forth. So you can be pretty sure that you've got only what you need for this user to fulfill its requirement of installing the connector. Create the policy. That now gets created. And from here, we can then go and create our user. Now we sort of have a choice. We can sort of put all this capability into a group first, and then instantiate users off that group if we want to with the same permissions. But we'll just add a straight user here. ArcSight connector user, for example. Documentation says to give actual management console access. Again, you don't really need to do this, but we'll pop it in anyway. Whether or not you have a password reset, completely up to you. In most circumstances, you would leave console access off. So we're setting the permissions now for the user. We can copy from an existing user. We can add the user to a group. So we can do it this way. You'll notice here that this ArcSight group has different types of policies attached. This is actually the user group for CloudTrail, which is a separate video. It's a separate connector, and we'll leave that out of scope for now. So this is purely CloudWatch. But we're going to attach these existing policies. So firstly, we'll go to our customer managed ones, the ones that we've created, and we'll attach these two as so. So these are the ones we just created. You notice that I've just selected them. I can then go and attach all of the other ones that I need to attach. And you'll remember that we've got quite a few here. These ones here. So what I tend to do is grab those names and simply paste them into the console itself. And so I can just grab it here, type it in there. I've still got my customer managed filter on, so just be careful of that. Bang, up it comes. You don't have to type in the full name either. You can just sort of make a start and you'll get a whole group of them, and then just pop in and just select the one that you want. But again, don't give full access if it doesn't need full access. Just do read-only access. Keep it as tight as possible. So I select that one. I've got that one now. I'll now pop in the name of my next one. Finds it for me. You notice that I can just keep selecting them as I find them. Bang, got that one. S3 access or read-only access. CloudWatch logs access. IAM I should say. And Lambda. And that's it. That's all of them. I can click next. I can click on review, and you'll see obviously it lists all of these different policies that I've attached to this user now, ArcSight Connector user. And now I can create the user. And this is where this programmatic access piece comes into play. You can download the CSV that will give you a copy of the access key and the secret ID. If you go and close this without downloading the CSV, or at least showing the secret access key, you are not going to be able to gain access to the secret access key ever again. It will be lost forever. You can email it. You can generate new ones and deactivate old ones if you wish in the console. So I'll download that. Got myself a copy of that. I'll keep that here, and I can now close that. So we're now done with this. There's my ArcSight Connector user. So the user side of things is now done. We're all set up and ready to go. Let's now pop over to the VPC console and actually start deploying the network that we're going to be using for our connector. So this is the VPC console. So you can select it by typing in the term VPC, isolated cloud resources, brings it up for you. And this is where all your networking stuff is basically. My VPCs, I've already got one, so I'm not going to create another one. The thing about the VPC is that you've got this IPv4 CIDR attached to it and this main routing table. And this is important because we're going to be creating new route table, a bunch of new subnets, and making sure that we have a public and private subnets for that matter. And we're going to be messing with the routing tables a little bit. We'll be updating those. We're also going to be creating what's called a NAT gateway, and that will allow the private subnets to actually gain access to the internet. And the reason for that is so Lambda, or our event processor / our smart connector, can actually get to the S3 bucket to grab the files that it needs, and also use S3 as its transport cache if need be. By default, Lambda does not have access to the internet per se, so you need to make sure that that piece of the puzzle is actually put together, or it will not work. So firstly, we've already got a VPC here, so a virtual private cloud, and that's fine. We've got an IPv4 CIDR of 172.31, and it's a /16. So basically anything within this CIDR is considered local. It doesn't really need to worry about, it's all handled internally, so to speak, via AWS itself. And within the VPC CIDR, and you can have more than one CIDR inside of a VPC, but inside we are going to create a bunch of networks or subnets. And with the subnets, when you create a VPC and you sort of use the defaults, it will give you a sort of like a subnet by default per availability zone. So I'm in the AP Southeast -2 region, and I have availability zones A, B, and C. So it's just like any other region, like North Virginia and so forth. They have multiple availability zones listed as such. And so the thing about these default subnets is that they're considered public subnets. By that we mean that when you want to go outside of these subnets, we actually have the traffic flow via what's called an internet gateway. So this is our default route. And we've got an internet gateway that's set up by default when we actually create this VPC. And so this is what essentially deems a subnet as being public. And the difference between that and a private subnet is that the private subnet doesn't have direct access to that internet gateway. We need to go via what's called a NAT gateway. And this is where some of the confusion lies, is that you think that, well, I can just get my Lambda function to actually go out to the internet via this internet gateway and my public subnet. Well, no, it can't. And secondly, the notion of a public subnet, it's not necessarily public, but what it means is you can set up public access if you wish. You can assign public IPs to it. So quite different to that of a NAT gateway is in that it is a NAT device, so to speak, a bit like your home router and so forth. So by default, I've got these 3 subnets. Now, I typically give them a decent name that makes it easy for me to find, because once you've got a bunch of subnets sitting here, it gets really, really confusing. So, and you do not want to be trying to remember subnet IDs. It's pretty hard. So what I've done is I've called it public, availability zone, and then the availability zone number. So it's public, availability zone C, AZA, AZB, right? So they're my 3 public subnets, and that's what a default VPC setup will give you. But now we want to create the private subnets across those 3 availability zones as well, and it's the private subnets that Lambda and so forth will take advantage of, and then we sort of link the 2 together between public and private to make it all come together. So let's create a new subnet now, and I'm going to call it private AZA. So what that means is it's my private subnet in availability zone A. The VPC is going to be the only VPC that I have. And in the availability zone, I'd like that to be availability zone A. Or in my case, availability zone 3, depending on how it's actually named. So it's a little bit confusing, the naming. I tend to go with the name itself and not the ID. And so I'm going to give this CIDR block something that falls within this CIDR range here, this /16, so 31.98.0, but of course it has to be a subnet of, so that should be valid. It shouldn't give me any errors. That's good. That falls within obviously the /16. If I was to do something like this is obviously going to give me an error because the address is outside of that CIDR within that VPC. So obviously we need to keep it inside of that. And so that's my first CIDR block that I'm going to use. I'll create that. Again, it gives it a subnet ID. We don't really want to have to remember that, so we've given it a good name instead. We'll create another one as availability zone B, same VPC. We'll go down to 2B this time. And you remember I used .98. I may as well use .99 here. Again, it's a /24 to fall within the CIDR block for the VPC, but obviously not overlap with any other subnet. So there's my second one done. And obviously you can guess what I'm going to do here. Private AZ3, same VPC, and we'll just make that 100. And that gives us our 3rd private subnet. So this just makes it a lot easier to read. You'll notice that in Amazon the default public public subnets tend to be larger than a /24, and that's completely okay. Doesn't make any difference whatsoever. Just gives you lots more IP addresses available to us. I tend to just do /24s where I can, hence I've got a much lower number here. So we're done here. These are our subnets. For the purpose of getting the actual system up and running, I'm going to basically designate this public subnet as the public subnet that I'm going to place my assets in, but then I'm going to actually give essentially Lambda access to these three private availability zone subnets. The next thing we need to do is then go down to our route table, and because by default these private subnets can't go anywhere, they can really only talk to themselves, and that's about it. So we'll go down to route table, and you'll notice this default route table that's set against the VPC when you create it, and again shows us what we saw before. This is essentially our VPC CIDR block range, and then anything bound outside of that goes towards that internet gateway, the target. And of course, our private subnets won't be going via this internet gateway. They will need to go via a NAT gateway. So what I'm going to do is create a new route table specifically for this for the private subnets. So private NAT route table. Just something easy to remember. Give it a good name, or you will get lost. And then, so there's our main route table. We've got our new route table. So what I do now is I need to actually, you'll see there that the VPC CIDR is still considered local, so that's great. But now I need to associate these subnets, these private subnets, with this route table. So in other words, I want these private subnets to utilize this particular route table. So I go over to subnet associations, edit the subnets, and here are all my subnets, but I'm going to include private A, B, and C, and that's it. Save that. And now I have those associations all done. And now what I want to do is create a NAT gateway. Because as you can see at the moment, just because I've associated the route table with these three subnets, it doesn't actually give them anywhere to go outside of those private ranges. So I need to actually create a NAT gateway for them. It's important to note they can't simply go out the internet gateway. It doesn't work. It doesn't happen. That's how it's designed. A private subnet cannot get access outside of the private subnet without going through a NAT device. In the past, Amazon, customers would simply put a NAT device in with an interface on the public subnet and an interface on the private, and then route the traffic out through there, and that would be the same thing. But in creating this private NAT gateway, it's effectively a managed service. And so you will pay for the NAT gateway if you don't set up your own router yourself. But for the purpose of the exercise, we'll create this NAT gateway here and now. So firstly, I need to place the NAT gateway into one of the public subnets. In other words, it goes into the public subnet and basically sits in between the private and the public and becomes that NAT router. And so I'm going to choose my public A network. And what you also want to do is associate an actual elastic IP. So that's where your final outbound address will be, what it will actually be. And then we create an actual gateway, and that's it. But you'll notice here that yes, we've created that network gateway, but now we actually need to associate the routes with the gateway and the subnets that will actually utilize them. And that is, of course, our private subnets. So we go to the private NAT gateway table, route table, and we're going to go to routes, edit route, and of course it's going to be a default route. And it gives us a choice here of our target of being any of these different types of gateway points. Amazon has a lot of different services that we can utilize here. Obviously this one, we're utilizing a NAT gateway. I only have one NAT gateway, as we just saw. I'm going to pop it in there. And there we go. So my 3 private subnets here now have a local route, but they now have somewhere that they can actually get out to the internet via, but they can't have anything incoming. And so we've effectively opened up internet access for a private subnet. And so it's again important to note that that is not the same as a public subnet. A public subnet can have public addresses assigned directly to the instances behind it themselves. So it's a route rather than an actual NAT. So that's important to keep in mind. Now, something that I've done that I like to do is to actually create a Windows jump host, and this is sort of cheating, making it easy for myself, but it's I've put it in the public subnet for now. You'll see there this Windows jump host is in this public subnet A, but obviously I can't get to those private machines. I need some sort of way of getting to them, so this is why I do it this way. And so what I need to do is now create a network interface on the one of the private subnets, so then my Windows host, I can attach that interface and then I can talk to the private interfaces via that jump host. And then there's plenty of ways to achieve the same thing, but this is the way I like to do it, because then I can have an SSH console, I can upload and download files easily and so forth. So private IP for Windows jump host, I'm going to assign it to my private A. What am I going to add, assign as my security group? At the moment, it doesn't really matter. Windows machine policy is probably just fine. And I'll go through the security groups in a second as well, because they also become important, and they can also be a cause of a headache whereby your connector is not receiving events, and we'll go through that soon. So here it is here. I like to just obviously again give it a decent name so we can understand, because these interfaces can fill out very quickly if you've got lots of instances, and it can become quite a pain to understand what we're actually looking at. Okay, so this private IP, I'll now attach it to my Windows host, and we're done there. That's great. It takes a few seconds, so it won't work straight away. And we also, at this point, may as well create our Syslog-ng connector box as well. So we'll go ahead and do that. Firstly, I'll just update my description of my private subnet A. Again, I like to do this just to make it easy to follow what I'm doing. So my Windows jump host is in public subnet A and private subnet A as well. So effectively, I've got that nice little way of being able to skip across the two networks into the private zone. And you'll see here 2 interfaces, ETH0 and ETH1. That ETH1 is my new interface. 98.83. You'll remember that 31.98 was my network for the private IP range in that first private subnet. So we're all done there. So I'll launch a new instance for our connector machine, and we can either use a pre-configured one. You might have your own AMI, it doesn't really matter. I've got a nice Linux host that I've previously had, and I've sort of kept it updated, so I'm just going to use that. Micro tier is fine. You can actually, for the purpose of a small connector, you can actually quite happily still use the micro size here. The connector will run on this okay, obviously not at a very high rate though. I'm going to pop it in the private A subnet. You'll see auto assign public IP is disabled by default. That is because it's going into a private network or a private subnet. Again, we cannot have public auto assigned public access to a private network or a private subnet. Everything else can sort of stay the same. No need for extra storage. This is not a particularly big device. If we knew what we were going to do a much higher EPS rate, we would obviously create a larger instance and probably maybe even a scaling type group, or utilize the ArcSight load balancer to do the same work at a much higher rate. I have a default machine policy here that I like to use. So these security groups you attach to effectively the interface, and this is one that I've obviously used in the past, and I'm allowing SSH from everywhere from now. But again, it's going to the private subnet, so it's only private subnets that are going to be able to get to this box anyway, so that's okay. I also tend to leave ICMP open as well for these private boxes, just so I can ping them, so I know everything's available. Good for troubleshooting. You can take that stuff out later on if you want, except of course SSH, and that will make for a nice clean private subnet. Everything's all good here. I'll launch that. I'll use an existing key pair, launch, and away we go. So that is now our Linux box for the Syslog-ng connector to actually be installed. Now I've got a filter here on my host instance states running, so that's why we don't see it here until it is actually running. If you have a lot of instances running in AWS, it can get quite messy, so I tend to keep it in a filtered state. The other one that we can actually do now is also launch the Amazon EC2 instance. And this is effectively this Linux box that will be running the actual connector install from. And this is basically the bunch of scripts and so forth that effectively programmatically configure and set up AWS with Lambda and Kinesis and everything that it needs to do to actually get CloudWatch running for us. And so this is an important piece to the puzzle. We have to do it from a Linux AMI, an EC2 Linux AMI for compatibility, and the actual AWS CLI, which is embedded into the EC2 instance by default. So that's why we utilize this, and we don't simply just do it on one of our vanilla CentOS boxes, for example. So this is the one we want here. Remember to choose x86, not ARM, as the architecture. Again, a micro box is just fine, doesn't need to be any bigger than that. And the difference here is that instead of placing it in the private subnet, we're going to be placing it in the public subnet. So that allows us to have a bit more flexibility in terms of connectivity and so forth. To the best of my knowledge, you could actually place this in a private subnet. I haven't tested it. It may in fact fail because it needs VPC level access to resources. So I'll put it in my public zone or public subnet. I'm going to have an auto IP assigned to it so I can get to it easily. That's cool. Everything else can sort of stay the same. No need for extra storage. 8 gig is fine. Nothing here on tag. Security group, again, I'm going to use that same security group that I like to use, which is here. Now this is, obviously a point of contention. Why would you allow ICMP to a public facing box? That's a good point. I can remove that later on. Just for the purpose of getting it set up, I'm going to leave it like that for now. And I can launch that. Again, key pair required. Launch. And there we go. This is actually my Linux host, of course. And this is going to be my Syslog-ng connector VM. And I also like to sometimes put in the actual IP address as well. It just makes it quick and easy to find what I'm looking for rather than coming down here to look for it. Right, so we now have our 3 hosts. Got a Windows host that's basically a jump box between public and private subnets. That's cool. We've also deployed our Syslog-ng VM, which is my nice CentOS AMI. And I've also dropped out a Linux EC2 instance, which is of course, the box that we actually run the installer connector configuration piece from, which does the programmatic setup of the AWS infrastructure and components for our connector. So that's all done there. The next thing to do is basically get onto the Syslog-ng box, install Syslog-ng, then you can grab the management certificate and so forth and bring it back and pop it into S3. So that's how I tend to do it. So I'm on my Windows box here now. I've logged into my Syslog-ng connector. I can run the connector, get it set up. One thing that I don't see mentioned in the documentation is that it is actually a TLS Syslog-ng. Not sure whether that's meant to be that way, but we'll make sure that we do that. So I'll install the connector. Alright, so I've now finished that piece. Again, this is a micro size instance, so it's not going to be particularly fast. It's all okay. In version 8 of the connectors, a Syslog-ng is number 126, so we'll select that, port 1999, and we choose TLS. Everything else I'll just leave as default. I don't have a logger or anything at this stage installed, so what I'll do is I'll just send it straight to a CEF file for now. Send it there. I'll do smaller files for testing. Alright, it's finally finished. And we're done. Start that up. One thing I like to do is to basically obviously got the agent.log file we can tail, but I tend to, just for the purpose of making sure we get this running and we actually see the traffic from Lambda itself, I like to just do a TCP dump on it just initially, so I can see the traffic, and then I know the network side of things is sound. So I'm done there. What I can do now is I can go to user agent, download those files that I need, the remote management stuff. I only need the P12 file, so I'll download that on my desktop. And I'll copy that, and I can send it to my S3 bucket. We'll get to that shortly. Okay, so I've taken a copy of that file. Now it's time to go over to the S3 console. And S3 is, of course, simple storage for Amazon. you go into the S3 console. I'm going to create a new bucket, and I'm going to give it a bucket name of my ArcSight. Well, my CloudWatch events. Keep note of the region because it's region specific. I'm going to Sydney, so I take note of that bucket name because I need to actually include that in my external.properties file. So that's important to note. There's really nothing else to do here other than just move it straight forward. In terms of access, make sure that you're blocking all public access. We don't need public access, so somebody with an S3 browser or something like that can't see the files. You don't even need to worry about do not grant Amazon S3 log delivery group write access. This works fine without doing that. So again, like anything else that's potentially public facing, keep it as locked down as absolutely possible. And so that bucket now just gets created. And we're done. So now I can go into that bucket, and what I want to do here now is create these different folders and place all the files that the documentation or the config guide talks about to actually for Lambda to actually read from. And so what I'll do here is I'll create a bunch of folders. I'm going to create a map folder for custom maps. I don't have any custom maps at this point, but I'll create it anyway. Transport.cache, so in other words, if Kinesis or Lambda finds any problems with connection to my Syslog-ng connector, it is actually going to start caching those events there. So that's pretty cool. I've got another one called properties. That'll be where my external.properties file comes from. And I also want one last one called certificates. And that's where my certificates are going to go. So I'll firstly go into certificates, upload a file, and that remote management P12 file. I'm going to drop that in there. Next, 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 all good. Upload. That's now done. Map files, nothing to go into there just that. Transport.cache, I'll leave that alone as well. Properties file, I now want to upload my external.properties file, and I'll find that here, upload, and I'll upload that there now, and I'll show you again what mine has in it so it's clear. So this is the external.properties file, and this is what Lambda, the event processor, will read to find what it needs in terms of configuration. Firstly, my host name is actually incorrect. I need to redo that. We'll do that in a second. But you'll notice that my certificate bucket is my CloudWatch events, which is what I just created, this my CloudWatch events bucket. Certificates, which is that subfolder that I created, and then the actual P12 file. Certificate.password is just the default for connectors. I haven't changed it. My send retries is 3. If you can't send an event after 3 retries, send it to this transport.cache subfolder in this same bucket. Last but not least, maps file as well, and then log level. Leave it as info. It gives pretty good information unless there's a real problem. So what I actually need to do is I actually need to update this first. And as you can imagine, I need to quickly just look at what the IP address is of my actual Linux host. It's actually .127. So what I'll do is I'll just update that to 127, save the file, and I'll come back here and I'll just quickly I'll just delete that one. So it's easy just to update it, send it a new one, it's all good, not a problem. Upload, next. That's good. Otherwise, the event processor would be trying to send syslog to a completely different IP address, so that definitely would not work. So that's that side of it done. The S3 side of it is now done. And so now we're basically ready to install the connector from the EC2 instance. So we're in a pretty good position now. But I'll quickly run you through what we're looking at here. So this is this CloudFormation piece, and this is where we create the stack, and the stack is then responsible for Lambda and Kinesis and all that sort of stuff. So as you can see, I've got nothing here right now, but this is where we'll start to see things pop up once we start the actual installation procedure. So we've got all our files in place. We've got our AWS access and secret key. We've got our Syslog-ng connector set up. Our S3 bucket is all set up. It's got all the files in it, etc., etc. So we're now in a position that we can actually go and install a connector. So let's go ahead and do that now. Here's our EC2 Linux instance. I'll zoom in a little bit so it's easier to see. Now I firstly need to obviously get the connector kit into the EC2 instance, which is quite straightforward. Right, so this is this actual CloudWatch connector zip that you'll find in amongst all the connectors. And there's obviously one for CloudTrail and Event Hub and so forth, but this is the actual CloudWatch one, so this is what's important. So as you can see, it's a bunch of scripts. I do know that I have made one mistake. There is a very important file that I forgot to place into the S3 bucket, so I'm going to go back and do that now. And that is, of course, the actual event processor jar, the actual code for parsing events. So, jar, I'll call it, upload, and you'll find your event processor -1.1.0.jar file in your connector zip file. Upload that once we're ready. And we can let that go. That'll be done in a couple of seconds. So what we've got here in the actual setup is a bunch of scripts. So what I want to first do is change the executable status for the SH files, and then we're going to run installer. And installer will basically take us through the whole process of setting things up. Now you'll notice that there's an event processor here, external.properties file here. They're all completely relevant. You can just delete those. They're not required. They're all sitting up in our S3 bucket right now. So we'll run the installer. And the first thing it's going to ask us for is our access key and so forth. So we need to give it that information. And this is, of course, the ArcSight connector user that we set up previously. So I tend to just keep these stuff ready to cut and paste. And it will authenticate and take us now to the region that we're interested in. In our case, it's Asia Pacific Sydney. And we've got a bunch of different deployment options here, but what we want to do is we want to do a fresh deploy. So we're going to basically deploy a new stack. So that is basically all the components. We want to do everything. So press deploy, takes us to our next screen. We're asked to give it a stack name. Now you'll remember that we didn't have any stacks to begin with, and we still don't. You can obviously have more than one stack as well, but we've got no stacks here. That's great. So I'm going to call it stack 001. This question here, do you want to create the flow components? Basically what it's doing is it's asking us if we want to set up the various log group components and also the flow log setup for the VPC at the VPC and subnet level. So in other words, it's sort of taking care of a lot of the groundwork for us. We don't need to go back into AWS and actually set up all those flow logs themselves, although we can if we want to. Now, the reason why I mention this is because if you've got other log groups you want to monitor and pull events down for, this question becomes significant, because if we say yes, it will automatically create them and then automatically attach to those log groups and pull those events down. But what it won't do is pull down other events from other log groups, in which case we will be asked later on, are there other log groups we want to actually monitor? So we'll say yes. That will save us a lot of work. How long I want to keep the logs for? 5 days is just fine. So this is this next piece that I was talking about, where is there anything else that you actually want to monitor? If you had other log groups that you want to take into account, you can do that here. So that just makes life a little easier for us to include those. So if I go back to the Amazon console and we'll go to CloudWatch. And under log groups, I've got nothing, and that's to be expected. If I had other log groups here that I wanted to actually pull in events for, I would make sure that I include those in here, and you'll see what a log group looks like pretty soon. So at this stage I'm going to say no, I'm not interested in anything here. VPC, obviously yes, it's my only VPC. The bucket that I'm interested in, yes, my CloudWatch bucket events, because that's the only bucket that I have. If I had other buckets, they would be listed here, by the way. Where's my jar key kept? And this is basically where we're telling the event, the configuration. Where do I find the event processor.jar file? And you'll remember that I actually had it under this my CloudWatch events jar file. So all I need to do here is put in jar / and then the event processor name, and that's it. So this is the subdirectory, then the jar file name, because I've already got the bucket name. We don't need to include that. The external properties key is obviously properties / external .properties on the same S3 buckets. So again, it's a subdirectory. And this is this private subnet that we're actually interested in being basically a part of. And having access to. So this will actually be the private subnet that we have the Syslog-connector running in. So if we go back here and just have a quick look at our networks or our subnets, you'll remember that we placed the Syslog connector into private A, which is this subnet here. So what you want to do is just take note of the subnet ID here, and I tend to just grab the last few digits, A86DA. So as long as I keep note of that, I know that I can match it down here, and that's the bottom one down here. So hit OK to that, and the port for the Syslog-ng is of course 1999. So you'll see here stack name, VPC, subnet, etc., etc. I am going to create the flow log components, and I'll show you later on what that looks like. Retention, the bucket, where the jar file is, etc., etc. Any other log groups to subscribe to at this point? No, although I could do it if I want to. Something you can do is with CloudTrail, you can actually publish CloudTrail logs to a CloudWatch group, and you could actually include those groups. So in theory, you could actually capture all of your events through CloudWatch itself, and not necessarily need a CloudTrail connector. So now we create the stack. And this is basically where the connector install is working in the background to create the stack, Lambda, Kinesis, the log groups within CloudWatch and so forth. So if we pop back over here now to the console, give that a quick update. you'll see that that stack is now in creation progress, and it actually takes a couple of minutes to do, so we can leave that be. You'll start to see more and more be created in terms of log groups and so forth as well. But this can actually take a few minutes, like I said, and if you click on the stack itself, you'll start to get some running information on it, and it can actually get quite verbose and useful. So we'll let that go, and when it's finished, we'll come back. All right, so the deployment has been successful. So that's this piece basically done. So we can quit out of that, and we can go back to our management console. So let's do that. Our stacks, create, complete. We're good there. One thing that is good to look at is now, if we go back to CloudWatch, we've got two new logs here. We will have another one actually come up shortly. Stack 001 log group, that's effectively our log group that will have per interface events flowing into it. So these log streams are effectively NICs or network interfaces within AWS. So if we can click on one of those logs, we should start to see something interesting, and sure enough, here's all the logs starting to flow in here, accepts and rejects and so forth. So that looks pretty good. You've also got this all-important one, this CloudWatch connector processing. So this is effectively agent.log, if you will, on a typical connector, and that's going to tell us how things are working, if they're working, and so forth. So we'll click on this. But what I will show you just quickly is what the connector installer has actually done with the flows. You'll notice that if I take a subnet, for example, and I go to flow logs, you'll see here that my stack 001 has created an actual flow for it. Destination type, CloudWatch logs. So that's great. So it's done all that work for me. I don't need to go in and create the flow log myself. You'll notice another one here, S3. So this is actually CloudTrail stuff. But this CloudTrail stuff could actually go to a log group in CloudWatch, and we could effectively do away with CloudTrail, the CloudTrail connector in that instance. And at the VPC level, you'll see here at the VPC level we've got another log group that's been created for us. So we'll slowly get more and more logs start to come through as traffic is generated. But that's the piece that the connector install, when it asks you, do you want me to create the flow log components, that's effectively what it's doing there. And then if we come back into log groups here, and there we go, finally. I've just been waiting for this heartbeat log to start as well, and that is, you remember that we've got the Lambda event processor, which is effectively our connector. Then you've also got the Lambda heartbeat, if you remember that from the architecture piece. That is effectively the heartbeat. Do we have connectivity and so forth? So that's that Python script that's also running in the background. So let's go to the event processing log now, because this is going to tell us whether things are actually working or not. Click on the log itself, and obviously I went to the latest log, and this is effectively agent.log, right? Everything's pretty good, but I've got here an error connecting to the destination. So in other words, I'm not able to connect to the Syslog-ng connector. That's okay. Let's go back to the first log, the very earliest, so we can see some of the other events that are occurring, and hopefully that will give us. Just wanted to show you some of the other messages that we should actually receive. Here you go, here, created the transport cache. And this is really important. Firstly, it tells us, yes, Lambda is connecting to S3 correctly. That's a big thing. That's really important. It's also telling us, hey, I've now created a bucket under cache transport. So in other words, we can basically say right here and now that that connection problem that we saw here, error connecting to the destination, there is a problem between Lambda and the event processor and our Syslog-ng connector. So we've got this error here now. We've also then started to cache those events. So we can come over here to back to S3, back to transport cache, and look at that. All of our events are now being dumped into S3 rather than going to the Syslog connector. So let's go to the Windows box and tail agent.log. And you remember that I set up TCP dump here, and guess what? I've got nothing hitting the interface. So there's obviously, it's not a connector problem, there's actually a network problem. So let's have a look at what it might be. And so everything else is fine. So what I'm going to do now is take a look at the actual permissions at the network layer as to who can talk to who. And is there something going on with my Syslog-ng connector which is stopping events hitting, or the Lambda event processor actually hitting my Syslog-ng box? So this is one of the first places you'd look. Am I seeing something here that might be causing me a grief? And if we look at the inbound rules, you'll notice that I've only got SSH and ICMP allowed. So in other words, Lambda cannot talk to the Syslog-ng connector for that very reason. So I need to put in an inbound rule. And in actual fact, the config guide does talk about opening up the necessary firewall rules for that to occur. And as you can imagine, all I need to do is add a new rule for custom TCP 1999. You could put in just the subnet, the private subnets if you wanted to, but just for the purpose of getting it running, I'm going to just open it up to everyone because it is on a private subnet anyway. Let's just get this thing working. So let's save that inbound rule. So I've now got port 1999 open. It's only going to be available to the private subnet, so that's not a big huge problem. So I've come back now to the actual TCP dump piece and nothing's happening. But guess what? We've got to wait for the next retry basically. So the connector will try again after a minute or two and we should start to see something pop up. So as you can see, it took a few minutes, but once it started, you can now see the traffic starting to come through. What's interesting is you can see where the source address is, of course, a device sitting on effectively our private subnet, our 98 subnet. So effectively Lambda, or the event processor, is a function on our private subnet. And if we come across here, we get a few error messages, as I've noticed, nothing terrible. But then if we go to opt ceph, we can tail that, and obviously here's all our lovely ceph. And so this is the CloudWatch connector all set up and done. If you want to save yourself that few minutes of no events coming through, make sure you place that that firewall rule in to open up port 1999 before you actually deploy the connector. That's a better way to do it, but it's a very good point where that will be the #1 issue in terms of not being able to find events being flowing through and hitting that interface. So hope you've enjoyed watching this video. Thank you for watching.